Long before whales sank through the oceans, before dolphins learned to breathe air and return to the sea, another lineage had already solved the same problem. The ocean had been abandoned once. When vertebrates first crawled onto land, the sea lost its largest inhabitants. But evolution rarely closes doors permanently. It experiments, it returns, and sometimes, it returns with precision. Ichthyosaurus was one of those returns. Its name means fish lizard, a label that reflects early confusion rather than biological truth. Ichthyosaurus was not a fish, and it was not a dinosaur. It was a reptile, descended from land-dwelling ancestors that made a deliberate journey back into the water. This journey reshaped everything. In the early Mesozoic era, the oceans were rich, warm, and largely unclaimed by large, fast predators. Into this space moved Ichthyosaurus, its body gradually transformed by the demands of speed, efficiency, and depth. Its silhouette tells the story immediately. A streamlined form, a powerful tail, paddle-like limbs pressed tight against the body. This was not an animal clinging to land-based design. This was an animal built for water. Unlike most reptiles, Ichthyosaurus evolved a body shape strikingly similar to modern dolphins and tuna. This is not coincidence. It is convergence. When evolution faces the same problem, it often arrives at the same solution. Speed mattered. The ancient seas were filled with swift prey, fish, squid-like cephalopods, and other marine reptiles. To hunt effectively, Ichthyosaurus needed acceleration, maneuverability, and endurance. Its crescent-shaped tail fin provided propulsion. Its stiff body reduced drag. Its limbs acted as stabilizers rather than paddles. Even its skin may have been smooth, minimizing resistance as it cut through the water. But perhaps its most remarkable feature lay within its skull. The eyes of Ichthyosaurus were enormous, among the largest relative to body size of any vertebrate known. These were not decorative. They were tools. Reinforced by bony rings, the eyes could withstand pressure at depth and gather limited light in dark waters. Ichthyosaurus hunted not only near the surface, but far below it. In the dim twilight of ancient oceans, it pursued prey with precision. Vision guided movement. Speed closed distance. Jaws snapped shut with efficiency rather than brute force. This was not an ambush predator. It was a pursuit hunter. Breathing air required regular returns to the surface, but Ichthyosaurus managed this constraint effortlessly. Its streamlined body allowed quick ascents and descents, minimizing vulnerability at the surface. Unlike land reptiles awkward in water, this animal belonged to the sea. Its bones tell us something else. Ichthyosaurus did not crawl ashore to lay eggs. It gave birth to live young. Fossils preserve mothers frozen in the act of birth, offspring emerging tail first, an adaptation that prevented drowning. This single trait marks a complete commitment to marine life. There was no return to land. The sea was no longer a hunting ground. It was home, and in that home, Ichthyosaurus thrived. As the ancient seas deepened and expanded, Ichthyosaurus settled into a role that few animals before it had mastered so completely. It was not merely surviving in the ocean. It was optimized for it. The structure of its skeleton reveals a life shaped by constant motion. Vertebrae were tightly packed, allowing the body to remain firm during high-speed pursuit. This rigidity prevented energy loss and allowed power from the tail to translate directly into forward movement. The result was efficiency, not exhaustion. Its flippers, often mistaken for paddles, served a different purpose. They stabilized the body, controlled pitch and roll, and allowed precise adjustments during pursuit. In fast-moving water, control is survival. Every turn mattered. Ichthyosaurus hunted primarily by sight, an unusual strategy among reptiles. Its massive eyes gathered light in the deep, enabling it to track prey far below the surface. Squid-like animals, early fish, and smaller marine reptiles formed the core of its diet. These were fast animals, capable of sudden direction changes. Speed closed the gap. Precision ended the chase. Unlike ambush predators that rely on surprise, Ichthyosaurus depended on sustained pursuit. This suggests high metabolic demands. While it was not warm-blooded in the mammalian sense, evidence indicates a metabolism more active than that of modern reptiles. Elevated body temperature would have supported long-distance swimming and deep diving. Such demands required constant feeding. The ancient oceans were rich. Nutrient upwellings supported dense food chains. Ichthyosaurus positioned itself near the top, regulating prey populations and shaping marine ecosystems through its presence. Remove such a predator, and imbalance follows. But Ichthyosaurus was not alone. Other marine reptiles shared these waters, plesiosaurs with long necks, early sharks refining the designs, and competing ichthyosaur species specializing in different depths and prey. Competition did not always lead to conflict. Instead, it drove specialization. Some ichthyosaurs evolved slimmer bodies for speed. Others developed larger skulls for powerful bites. Diversity increased as niches multiplied. Social behavior remains uncertain, but evidence suggests at least temporary groupings. Mass fossil sites indicate that Ichthyosaurus may have traveled in loose aggregations, perhaps following seasonal prey movements or congregating in breeding areas. Such behavior would have reduced individual risk and increased hunting success. Reproduction, too, reflected advanced adaptation. Live birth freed Ichthyosaurus from the constraints of land. Young were born fully formed, capable of swimming almost immediately. Parental care, if present, was likely brief. Survival depended on instinct rather than protection. The ocean offered no shelter. Every movement occurred in open space. Vulnerability was constant. Only speed, awareness, and endurance allowed survival. Ichthyosaurus embodied all three. Its success spanned millions of years. From the Triassic into the Jurassic, ichthyosaurs diversified and spread across global seas. Their fossils appear on multiple continents, evidence of oceans without borders. Yet even mastery has limits. As environments shifted, prey populations changed. New predators emerged. Competition intensified. The balance that once favored Ichthyosaurus began to strain. Still, it endured, longer than many. Its story, however, was approaching a turning point. As the Jurassic period progressed, the oceans that once favored Ichthyosaurus began to transform. These changes were not abrupt. They arrived gradually, disguised as normal variation, but carried long-term consequences. Ocean temperatures shifted, currents altered, prey distributions changed in response. For a predator built on precision, even small disruptions mattered. Ichthyosaurus had thrived in environments rich with fast-moving prey and stable food chains. As ecosystems diversified, competition intensified. New marine reptiles emerged with different strategies. Plesiosaurs adapted long necks for ambush feeding. Sharks refined their cartilaginous skeletons, gaining maneuverability and resilience. The ancient seas became crowded. Ichthyosaurus did not disappear immediately. Its decline unfolded over millions of years. Fossil records show a reduction in diversity, then in abundance. Some lineages adapted briefly, adjusting size and hunting behavior. Others vanished quietly, leaving only fragments behind. By the late Jurassic, Ichthyosaurus itself was gone, replaced by more specialized descendants and competitors. Extinction, in this case, was not failure. It was transition. Ichthyosaurus had already achieved something extraordinary. It demonstrated that reptiles could return to the sea and dominate it completely. Its body plan proved so efficient that it would reappear again and again in unrelated lineages, most notably in modern dolphins and whales. This is the power of convergence. Different paths, same solution. Scientifically, Ichthyosaurus reshaped paleontology much as Iguanodon had on land. Early fossils were so complete that they challenged prevailing ideas about prehistoric animals. The discovery of live birth stunned early scientists, proving that complex reproductive strategies existed deep in time. Ichthyosaurus erased the boundary between ancient and modern marine life. It revealed that intelligence, adaptation, and specialization were not recent innovations. They were ancient. Today, its fossils remain among the most recognizable marine reptiles ever found. Their streamlined shapes speak instantly to motion. Even in stone, they appear to swim. In museums, Ichthyosaurus is often displayed mid-dive, jaws open, body curved in pursuit. These poses are not artistic exaggerations. They are reconstructions grounded in anatomy and physics. They tell a simple truth. The ocean rewards those who become part of it. Ichthyosaurus did not conquer the sea. It surrendered to it. In doing so, it became one of the most successful marine predators of the Mesozoic era. As sunlight fades into deeper water and pressure rises beyond human reach, the memory of Ichthyosaurus remains, etched into rock, preserved in silence, moving forever through ancient seas that no longer exist.